Okay, so today we want to go through and we want to use best testing practices to be able to find the answer without necessarily understanding mathematically how it works. So in this problem, I will tell you that a common mistake students make, don't do this, just watch, is if they plug this in, they plug in 2x minus 1, they cube it, and then they want to go subtract 27. Can everybody see this? But guess what the calculator thinks this is? The calculator thinks this is 2x minus 1 raised to the negative 24. Can everybody see that? Because you're not using parentheses right. So I may teach you a longer way to plug this in, but to ensure that you're going to get it right. We want to use this quantity 3 times. Everybody please do this with me. We're going to plug this in 3 times. Here we go. 2x minus 1 times 2x minus 1 times 2x minus 1. We did it 3 times because it's cubed. Now subtract 27. Hit graph. And just visually, I'm going to plug these in one by one, and I want to find out which one is identical to this graph. It's as simple as that. So let's start off with A. By the way, I'm trying to teach best testing practice, so if there's a faster way to do something, we're going to use the faster way. So let's type in 2x minus 1. I'm currently typing in what I see in option A. So I've typed in option A, making sure there's no mistakes, and I hit graph. Do you see right away that they're not the same graph? Okay, hold on before you delete anything. So I'm trying to teach you how to do this, take this test faster. Go back and hit y equals. Instead of deleting the entire second graph, it starts off with a 2x minus 1. I'm going to cross off option A because they're not the same visual graphs. Let's go on to option C. Do you see how they start off with the same thing? I don't have to type in the entire second equation. We already have 2x minus 1. We already have 4x squared. Now it needs to be subtract 10x plus 13. So I'm only changing part of it. It saves me some time. I graph it. There's the first equation. The second should go right over the top if it's the same equation. It does not. I cross it out. Let's go to option B. Option B now is 2x minus 4. 4x squared minus 10x plus 13. Everything else stays the same, and I graph it. Okay, they're very close, but they're not identical, so I cross off B. And let's just make sure. D should be correct because there's only one other option, but what do I need to change here? I have 2x minus 4. I have 4x squared plus 2x plus 7. I graph it. This tells you it's processing it. There's the first function graphed, and the second function is currently graphing. We don't see it, so guess what? It's right over the top of it. They're the exact same ones. Done. Can I have a thumbs up or a thumbs down if you understood how I just did that? Okay, let's go on right now to option number 2. Can you do me a favor? Can you please write, well, that's okay. We'll leave it as this. So we have this expression, and I want to know which of the following is a factor of it. So if it's a factor, I can do something really simple. I can graph this as if it's a function, and if this is a factor, it means that, please write these down, it means we have x-intercepts at -2 if A is correct, -4 if C is correct, +3 if B is correct, and an x-intercept at -5 if D is correct. Remember, the factor and the actual corresponding x-intercept have different signs. So I'm going to clear my calculator and I'm going to go to y equals. Make sure you're using parentheses. X to the 4th, subtract 27x squared. Notice there's no x cubed in this one. Don't make that mistake. Subtract 14x plus 120. I graph it. And it says, which of the following is a factor? Okay, so let's check here. I'm going to check A. I want to know, is -2, it doesn't appear like it, but is -2 an x-intercept? Second trace value, type in -2. It is not an x-intercept, cross out A. Let's check -4. Second trace value, is -4 an x-intercept? It is. -4 is an x-intercept, which means x plus 4 is a factor. Problem done. Now, be careful. If the wording said select all of the factors, then you'd have to continue checking the others. Okay? Do second plus 7, 1, 2. Circle all of the roots. Well, let's first put this all on one side. So let's write down x cubed, subtract x squared. Now, when this 4 comes across, it was positive. When it comes across, it becomes negative. And when the negative 4x comes across, it becomes a positive 4x. Go to y equals x to the third, subtract x squared, plus 4x, subtract 4. Graph it. I see only one x-intercept. Please circle this cube. How many answers do I want?
3.
But in this case, there is one real, and there's 2 complex, also known as imaginary. Now, I need to identify all of them, as we can see, all of them. So it looks like this is maybe a 1. Just to be lazy, let's check a simple way. Go second, trace, value, type in a 1. You're right, or I'm right, I should say. 1 is the x-intercept, so let's circle 1. Now, how do you find the complex? You can find the complex using synthetic division. So, x to the third, 1x to the third, subtract 1x squared, plus 4x minus 4. This will allow us to go from x to the third, a third degree, down to a second degree. Bring down the first, synthetic division. Multiply, add down. Multiply, add down, multiply, add down. I knew it was going to work. I knew it would be a 0 because the graph showed me that. So why am I taking time to do that? And here's the reason. We go from a third now down to a second. Please write 1x squared plus 0x plus 4 equals 0. We need to find all of the roots. What always works? If you don't know how to factor, what always works? Quadratic formula. But you know what? Here's an easier situation. When there's no middle term, even easier. So yes, you could use quadratic, but this is even faster since there's no middle term. Move the 4 to the opposite side by subtracting. Get rid of the square by taking the square root, but you can't take the square root of a negative, so the negative comes out front and becomes an I. The square root of 4 is 2. Here's 2 answers, plus 2i and minus 2i. The third is positive 1. Number 3. If you did not know, I graded period 1 yesterday. It took me 3 hours outside of school to grade first periods. So I will begin grading yours at the conclusion of this page. First period did excellent on, there was a problem on the front page where you had to do long division. So I assume that possibly your class did the same. So let's do long division here. We have 4x minus 1 on the outside, and the inside I have 12x squared plus 5x minus 1. (4x) times what quantity equals 12x squared? The answer is 3x. Multiply, multiply, change the signs, add down. 4x times what equals 8x? 2. Multiply, multiply, change the signs, and add down. So what does my answer look like? So it's 3x plus 2 plus 1 over 4x minus 1. Where is this answer? It is option A. Number 4. Number 4. We want to sketch a rough graph of a polynomial that has zeros or x-intercepts at -2, +1, and +3. It also has an end behavior that follows this. As I go to the far left, it goes down. As I go to the far right, it goes up. Now, how do I connect those two? Which direction am I headed right now? Up and then back down. They're just asking for a rough sketch. Go on to number 5. Number 5 is like number 2, which we've already completed today. Which one of the following is not? Please box this in. Which one of the following is not a factor? So if this is a factor, it means the x-intercept would be -1, +4, -2. And I can see where there'd be some confusion with B because it looks slightly different. Well, how do we actually come up with these answers? We take this factor, in this case 2x plus 3, and we set it equal to 0. Subtract the 3, divide by 2, and -3/2 is the same as -1.5. Grab the graphing calculator and please do second plus 712. Let's type in the expression we see. 2x to the 5th, make sure you're using parentheses, plus 3x to the 4th. Subtract 30, x cubed, subtract 57, x squared, subtract 2x plus 24. Which one of the following is not a factor? So we can do the opposite. We can identify all the factors or x-intercepts, and whatever is not identified then would not be a factor. So let's do this. Is -1 an x-intercept? Let's go quick. Second trace value, type in -1. -1 is an x-intercept. That means this is a factor, and we're looking for things that are not factors. Let's check 4. Second trace value, type in 4. 4 is an x-intercept. That means x minus 4 is a factor. We're looking for things that are not factors. Let's track -1.5. -1.5 is an x-intercept. That means this is a factor. And so the answer should be D, but let's check it. Type in -2. We can see -2 is not a factor. So this is not, sorry, -2 is not an x-intercept. So this is not a factor. Which one of the following is third degree? Can everybody write x cubed? Which of the following is third degree, but it only has roots at -3 and 2? There's no other roots. So let's go second plus 712. When you look at options A through D, I can already eliminate one before I do anything on the calculator. What can you eliminate? Why? Good. Okay, let's try C. So I'm going to go x to the 3rd. Use your parentheses when needed. And graph. I can already stop. How many x-intercepts do you see? But how many can we only have? Okay, done. So I know it's not C. Let's go on to B. So I get to leave it as x cubed, but now I want 4x squared, subtract 3x, subtract 18. So I only had to edit it. Saves me a little bit of time. Okay, well this only has 2 x-intercepts. Now let's see if they're the exact same x-intercepts that we want. Second trace value, type in -3. -3 is an x-intercept. Second trace value 2. 2 is also an x-intercept. Write down all of the factors. Write down all of the factors. So please do second plus 712. All right, let's type it in together. So to find all the factors, I know that I want to have 3 roots, whether they're real or complex. And the best thing here is this makes life pretty easy for me. The roots are all real. So let's identify the x-intercepts. And again, I'm taking a test. If there's a faster way to do something, I want to do that. 1, 2, 3, 4, 5. It looks like 5 is an x-intercept. Let's cheat and see if it is. Second trace value. 5 is an x-intercept. So if this is an x-intercept and I want to write this in factored form, I don't write x plus 5. It is x subtract 5. And it looks like 1 is also an x-intercept. Let's check. 1 is an x-intercept, so it's x subtract 1. And I can see that this final x-intercept is not an integer. So I'm going to go second trace 0 and go through this the longer way. Okay, so I'm going to go right now. Left bound is below. Press enter right, or 1 time. Right bound is above. Press enter 1 time. And I go back to the x-axis and I press enter. So negative 6.6 repeating is the same as negative 2/3. So negative 2/3, but I have to do the opposite. So if you did this for a test, for me, I would not count it wrong. But you're not going to see a multiple choice test like this. What's the slight difference I need to make? What would you see? Close, very close. Bottoms up, 3x plus 2. This is what you would see, okay? This is equivalent, it works for me, but in factored form, they like to push that up.